Let's do another example. Here you can see I've got the function f of x equals negative x cubed plus 4x squared plus 3x plus 3. And this question asks us to find the relative minimum and maximum of the function. So let's go ahead and do that. In order to do that, we need to first take the derivative. So we need to find f prime of x. And hopefully by now you can do this quickly. The derivative of negative x cubed will be negative 3x squared. Then we have plus 8x because the 2 comes down and multiplies with the 4. 3x then becomes plus 3, and the other 3 cancels and just goes away. So our derivative is negative 3x squared plus 8x plus 3. In order to find the relative minimum or maximum, those occur when the first derivative is equal to 0. So I just set that equation equal to 0. So now we just need to solve this, and hopefully it will factor, and in this case it will. Remember that it's easier to factor something like this if the first term is positive. So let's go ahead and multiply the entire equation by negative 1. That'll give us, if we do that, that will give us 0 equals positive 3x squared minus 8x minus 3. Okay, so 0 equals positive 3x squared minus 8x minus 3. And that will factor. By playing around with it a little bit, you'll get 3x and x. And we need negative 8, so I'll put a negative 3 here and a positive 1 here. Or you could use the quadratic formula to solve this equation. That means that we have 0 equals 3x plus 1 and 0 equals x minus 3. So those are going to be our two roots of this quadratic. And so what I can do next is I can just solve those. If I solve this first one, I get x equals negative a third. If I solve the other one, I get x equals 3. So those are my two candidates for relative mins and maxes. And so what we need to do now is to determine if they are mins or maxes. And we can do that by using the first derivative test and looking before and after to see what happens. So let's start with x equals negative a third. I need to pick 2 points that are fairly close to it, that on either side, and see what happens. So what I'm going to do is I'm going to pick the points negative 1 and 0. Notice that I picked 2 points that are close by that are on either side of negative a third. Now what I'm going to do is we're going to look at our first derivative and see what happens as I plug in these points. So let's start by plugging in 0 because that's easy. That'll be 0, that'll be 0. And so I get 3, which is positive. So the function is increasing right there. If I plug in negative 1, this is negative 3. This will be negative 8, which is negative 11. Plus 3 is negative 8, so this will be negative. So we're decreasing. So that means this negative 1/3 is going to be a minimum, a relative minimum, because we're decreasing, we hit the 0 at negative a third, and then increasing. So negative 1/3 is a minimum, and if you plug in negative 1/3 into the original function, you should get 67 over 27. So I've already done that off on another paper, but if you were to go ahead and plug that in, here is a relative minimum. Okay, now let's look at the value x equals 3. Is this going to be a minimum or a maximum? Let's find out. Let's try plugging in the values 2 and 4 into the first derivative and see what happens. So if I plug in 2 here, I get 2 times 2 is 4, times negative 3 is negative 12, plus 16 plus 3. So that's going to be positive if I plug in 2. That's going to be positive right there. What happens if I plug in 4? If I plug in 4, I get 4 times 4 is 16, times negative 3 is negative 48, plus 32 plus 3. And that negative 48 is going to just swallow everything. So that means we're negative right here. So what that means is that we go from positive to negative. And the first derivative test tells us that when that happens, that means that this is a relative maximum. So if you plug 3 back into the original function, you should get a value of 21. So that means that this point right here is a relative max. And our earlier one was a relative min. And that's how you do these. It's just a matter of understanding how the first derivative can tell us where relative maxes and mins are located. In the next video, we'll do another example.